Imagine looking into space and seeing something deep and mysterious, challenging everything we know about the universe. It's a surprising discovery that raises questions about the structure of reality itself. This is not just science fiction. The world's dramatic spectacle, seen through the unblinking eye of the James Webb Space Telescope. The discovery could rewrite our understanding of the universe's origins, suggesting that the universe is older, much older, than we thought. The heart of this cosmic mystery is a star 200 light-years away in the constellation of Libra. Known as HD 140283, the star of Methuselah, this star has become a paradox in world history. According to previous estimates, the star is 16 billion years old, which contradicts the age of the universe itself, which is estimated to be 13.8 billion years. Despite the latest calculations, which determine the age of 14.46 billion years with a margin of error, it is still much older than the inhabited world. Are we completely wrong about the Big Bang theory, or do we need to revise our methods of determining the stars and the universe? For nearly a century, the Big Bang theory was the cornerstone of the universe. It is estimated that 13.8 billion years ago the universe began as a single, infinitely dense point that expands and continues to grow today. This expansion was first observed in the 1920s by Edwin Hubble, who suggested that galaxies are moving away from us at a rate proportional to distance. This discovery laid the foundation for our understanding of the age of the universe. However, the discovery of Methuselah's star suggests that the universe is more complex than we thought and may be older than the Big Bang itself. The star of Methuselah is not just any star. It is what astronomers believe to be a second population of stars, emitted from a time long before the birth of our Sun. These stars are poor in heavy matter, indicating that they formed in a universe that had not been enriched by the supernovae of previous star generations. At the very least, the mass of this star indicates that it formed early in the history of the universe, but its age calculation remains a major challenge for our current models. Could this star be older than the universe, or is an important piece of the puzzle missing? Some scientists are beginning to explore the idea that the universe may be older than we believe. According to a new theory, the universe is 26.7 billion years old, almost twice as old as before. The theory resurrected an old idea from 1929 called expired light, which says that as light travels through space it loses energy, possibly becoming more global inflation. If true, this does not simply explain the age to Methuselah's star, but also determines the difference in measurements of the Hubble constant, a quantity that reflects the speed of the universe's expansion. To understand this, imagine compressing the entire history of the world into 1 year. In this world calendar, the Big Bang occurs at midnight on New Year's Day. The Milky Way doesn't form until late March, our solar system appears in early September, and humans don't appear until the last few seconds of December 31st. If a 26.7 the universe is billions of years old, and this calendar is beyond our imagination, changing our understanding of time and space. As we look closer to home, we discover a mystery in our own Milky Way galaxy. Recent measurements show that stars outside our galaxy are moving faster than expected. This may be due to the presence of dark matter, invisible matter that does not emit, absorb, or reflect light, but exerts a strong influence on visible matter. The European space probe Gaia has provided a map of nearly 2 billion stars, allowing astronomers to study the distribution of dark matter with great precision. Dark matter is important to understand because it is a large part of the mass of the universe and plays an important role in the formation and evolution of galaxies. The discovery of the star of Methuselah and the possible change in the age of the world is not a mystery. It's a piece of a bigger heavenly jigsaw. Each new observation, each new anomaly, forces us to re-evaluate what we thought we knew about the world. The James Webb Space Telescope, with its ability to peer deeper into space and back in time, may uncover other surprises. As we continue to explore the world, we must be open to the idea that our current concepts are the beginnings of a deeper understanding of the world. One of the biggest challenges in astronomy is accurately determining the age of stars. Unlike humans, stars are not scattered in an easily visible form. Their brightness, temperature and size remain constant for billions of years, making it difficult to determine their age. Astronomers rely on several methods to estimate the age of stars, such as watching changes in a star's brightness and color, or measuring its rotation speed using a method called gyrochronology. Another method, called asteroseismology, is the study of oscillations or stars in a star, which can provide clues about its internal structure and age. But these techniques can also create uncertainty, as shown by the star of Methuselah. The implausible age estimate challenges our confidence in these methods, and suggests that there may be factors influencing stellar aging that are not fully understood. The star Methuselah belongs to a group called secondary population stars. The age difference between Methuselah's star and the universe is not the only challenge facing the cosmologists. Another important factor is the so-called Hubble expansion, a variation in the measured expansion rate of the universe. Hubble's constant, named after Edwin Hubble, is a quantity that describes the rate of expansion of the universe. However, different methods of measuring this constant produce different results. Observations of the microwave background, the radiation left behind by the Big Bang, indicate a slower rate of expansion, while measurements of supernovae in distant galaxies indicate a much higher rate. This conflict between different measurements suggests that there may be some unknown phenomena that may point to new physics beyond our current understanding. The implications of solving this problem are profound, and may lead to a revision of the age of the planet and our understanding of its expansion history. The theory of exhausted light, first proposed by Fritz Zwicky in 1929, is a possible solution to the mystery of the star Methuselah. According to this theory, light loses energy as it travels through space, which may explain why the universe seems to expand at different rates depending on the shape of the universe. Measure. If the moon were to lose its power in the distance, our judgments about the universe's expansion, like its age, may end. Although the faint light theory of the Big Bang model has been dismissed, recent discoveries such as the Methuselah star have prompted some scientists to re-examine the idea. If the faint moon is indeed a phenomenon, it could not only explain the star's changing age, but also determine Hubble's gravity and provide a better picture of the history of the star. World. However, this theory is still controversial and requires updating our current understanding of the planet. Unfortunately, it is one of the most mysterious parts of the universe, and it plays an important role in the formation of galaxies and their evolution. Although dark matter does not interact with light and cannot be seen with a telescope, dark matter has an effect on the motion of stars and galaxies. Recent observations from the Gaia satellite have revealed that stars on the outskirts of the Milky Way are moving more slowly than expected, suggesting that dark matter might be more evenly distributed than previously thought. Understanding the distribution and behavior of dark matter is essential for explaining the formation and structure of galaxies, including our own. If dark matter interacts with regular matter or with itself in ways we do not yet fully understand, it could also have implications for our estimates of the universe's age and expansion rate, potentially offering another piece of the puzzle in the mystery of the Methuselah star. As we gather more data and develop more sophisticated models, our understanding of the universe's history continues to evolve. The discovery of the Methuselah star and the ongoing debate over the Hubble constant are reminders that cosmology is a dynamic field, where new evidence can overturn long-held theories. If the world is older than we believe, this could have major implications for our understanding of the history of the world. This means that the early universe was more complex and evolved faster than we thought, which may have led to the formation of stars and galaxies earlier than our current models allow. We need to revise the timeline of the world's major events, from the formation of the first stars to the evolution of galaxies and clusters, to the emergence of life itself. The mysteries surrounding the star of Methuselah and the age of the planet show the importance of continued exploration and research of the planet. As our tools and techniques improve, we may discover more hazards and challenges that push the boundaries of our knowledge. The James Webb Space Telescope, with its ability to peer deeper into space and time, will play an important role in this search. Each new discovery, whether it confirms or challenges our current theories, brings us closer to a better understanding of the universe. But as we solve a mystery, new questions inevitably arise, knowing that the journey of discovery is far from over. In this sense, the world itself is a great mystery that is still being discovered, and our quest to understand it is a sign of humanity's insatiable thirst for knowledge and understanding. The journey to discover the mysteries of the world is not over. The discovery of a star older than the universe challenges the foundations of modern astronomy. Whether it leads to a fundamental revision of the Big Bang theory, a new understanding of dark matter, or a complete overhaul of our timeline, one thing is for sure: the pursuit of knowledge continues to push the boundaries of what we know. As we stand on the threshold of these profound discoveries, we are reminded that the world is not only more than we think, but more people than we think.